Hey there, students, college trigonometry. I missed you so much. I want you to know that truly these past couple of weeks in spring break, it's been a time where I thought about you a lot, and I more than anything wish that we could be in the classroom together, especially you seniors. This is your last time, last quarter, but this is the situation we're in, and so I had to decide what mode of delivery I would bring to you for these lessons. And I really felt like if you saw me, not that I'm anything to look at, but I just felt like if we were able to see a little bit of interaction, that you were able to see me on the screen instead of maybe just viewing my hand writing some problems or watching a previous video. This might add a little bit more of humanity to, I guess, your work. And so here I am. This is my dry erase board I built in my house. I'm in the middle of, I guess, yeah, this is my, see over there, this is my kitchen that I'm working on, the remodeling project, as we talked about, as I showed you guys earlier. Over here, just a view outside my window and whatnot. This is kind of the, I guess we flip all the way around. Now you're getting dizzy, aren't you? The piano where my kids practice, and there's a hutch there with some animals for my aunt. Yeah, here's kind of Ghent Central right now. We've got all sorts of things ready to go for different people. My kids are all kind of have their stations for relearning, and this is, or distance learning, excuse me. This is my spot for distance learning. So here's the delivery. So we're going to have a few lessons to get through, a few different topics. And I want you to know that we're definitely going to slow the pace from what we've done in previous years. We're going to really just give you what I believe is the essential content and make it as user-friendly as possible. So please make sure you look at that week one, submit your attendance, but look at that week one and make sure that you identify exactly the things that you need to complete by Sunday night, 11:59. And so the topic for today is graphing complex numbers and finding the modulus. So as we just kind of talked about graphing a number, I want you guys to understand, if I have the number 5 and the number -3, and you want to be able to plot those numbers, well, we've always just had a nice number line, and you'd be 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So you would plot 5 right here. That would be number 5, and then -3 would be right here. And those are your numbers that you plot on a number line. So you're like, well, that's no big deal. Well, the question is, where does this point go? So 2 minus 3i. Where does that go on this number line? And the fact is that we don't know where that number goes on that number line, because this has a real part and it has an imaginary part. And that's what we call a complex number. And if we want to be able to graph a complex number, we need more than simply just a real number line. We need a complex plane. And complex plane is made up of 2 axes, the real axis and the imaginary axis. So we have the real axis and we have the imaginary axis right there, okay? And so if you're going to plot this number, 2 minus 3i, it's pretty straightforward. We go over 2 on the real axis, and we go down 3, 1, 2, 3 on the imaginary axis, and we plot it right there. Now, it's not just a point, it actually stems from the origin and goes to that spot right there. So that's how we graph a complex number, okay? So that's graphing it, no big deal. You have the real part, you have the imaginary part. The question is, what about its modulus? Well, the modulus is simply the absolute value, the absolute value. If I were to ask you the absolute value of 5, you'd tell me the absolute value of 5 is in fact 5. And if I asked you the absolute value of -3, you say the absolute value of -3 is 3. Why? Because that's how far away it is from the from 0. That's our definition of absolute value. How far is the number from 0? Well, if you want to consider this one, going to get a little bit more in depth here. This is kind of it's not difficult to do, but it's a little bit more the meat of the lesson for you. If we want to consider any complex number, a plus bi, and you want to find its absolute value, if you were to plot a plus bi, you would go over a units and say up b units, say something like that. And if you want to find its distance, so we call this the absolute value of the complex number. We use the variable z, the absolute value of z. The way that we find the distance that this is from the origin is we use the Pythagorean theorem. If you notice, we go over a units and we go up b units. So therefore, the absolute value of any complex number, or its modulus is absolute value of a complex number. The absolute value of that is equal to simply just the square root of a squared plus b squared. And that's the formula. Now, what should you be doing? If I were you, I would kind of take down some of these notes, the really important parts, especially the examples I go over, because you get to use those notes on your assignments, and you get to use your notes and your assignments on your tests. Those are open note, open video. It's not open person. It's not open internet. It's not open phone, but you can use those things. So we're going to do a few examples here where we graph a complex number and we find its modulus. And we're going to do that and make sure that you're good to go and on your way. This is obviously a very important equation that we want to be able to use during this time. So let's get started. Got example 1 and example 2. Example 1 is z is equal to -1 plus 4i. And example 2 is going to be 3 minus 2i. Okay, so we're going to graph those and we're going to find the modulus. So as I graph it, I go back 1 and I go up 4. So back 1 and up 4, I plot that and then draw that line. For this one, I go over 3 and I go down 2. And that's my modulus, over 3 and down 2. I'm sorry, that's the graph of the complex number. Notice this one places me in the second quadrant. This one places me in the fourth quadrant. That's going to be important for our videos the next couple days. But now that we have those graphs, we want to find the modulus, or the absolute value, okay? So the absolute value of z, or the absolute value of -1 plus 4i, is going to be, here's what we write, and this is how you're going to want to write it in your, so for your assignment, you don't have to graph it. It's kind of tough to be able to show that work. But when you use the equation editor, this is what you're going to write. We take the square root of -1 squared plus 4 squared. Notice I don't square the I. Okay, you don't include that. That doesn't account for the distance. The I just tells us we're on the imaginary axis. So I get the square root of -1 squared is 1 plus 4 squared is 16. So I get the square root of 17. And that's simply just the work that you would show. So that's the first thing that you're going to have to be able to do for your test. And on your assignment as well, we're just finding the modulus, which is the absolute value of the distance from 0. Okay. This one, the absolute value of z is the absolute value of 3 minus 2i. That's going to be equal to the square root of 3 squared plus -2 squared. Notice when you square something, it always becomes positive. Square root of 9 plus 4. So I get the square root of 13. Okay? So there's 2 examples. We're going to do 2 more, and then you'll be set to be able to do that assignment. right now you're thinking to yourself, well, this is just Pythagorean theorem, Mr. Gens. It is. This is kind of the brief investigation, what we call complex analysis. So if you were a math major, you'd take a course called Real Analysis, 100%. It's a proof course. And then you would choose possibly to take a complex analysis course where you're dealing with imaginary numbers. And yes, it is a Pythagorean theorem. The reason why this is part of trigonometry is because it incorporates the Pythagorean theorem, which I think everybody knows is the fundamental idea behind trigonometry. Okay, for this one, we're going to go square root of 5 plus I, and then we're going to do negative 5I. So this one's a little trickier. Square root of 5 plus I. So square root of 5, that's about like 2.2, something like that. So I'm going to go over about 2.2 units. And then what's the number in front of I? That'll be a 1. So over 2.2, maybe we could go a little farther. Just draw it like that. That's the graph of square root of 5 plus I. And then negative 5I. Notice in this case that there is no real part. Okay? Like in this one, square root of 5 is the real part. 1 is the imaginary part in front of I. And then here, you don't have anything. So we don't have anything on the real axis, but the imaginary axis, we drop 5. So I would put a dot, draw that line down. It's just right along the imaginary axis, which we often think of as the x or y-axis there. So now you want to be able to find the absolute value. So the absolute value of z is equal to the absolute value of the square root of 5 plus I, which is going to be, I'm sorry, the absolute value of square root of 5 plus I, which is the absolute value of, I take the square root of 5 and I square it. And then the number in front of I is 1. And I square that. And so I get the square root of, square root of 5 squared is 5. And 1 squared is 1. So we get the square root of 6. And that's your result. Okay, that's the absolute value, or the distance it is from 0. For the next one, the absolute value of that z number is equal to the absolute value of negative 5I. That's equal to the square root of, what's the number for the real part? That would be 0, so 0 squared plus negative 5 squared. And I get the square root of 0 plus 25. And 0 plus 25 is 25, and the square root of that is 5. Now, this is something that's important. I want you to understand, because right away from the very beginning, we could have identified exactly what the modulus was, what the absolute value was. Because remember, the modulus, or the absolute value, is the distance from the origin. Look, how far is this from the origin? It's 5 units. Okay, so sometimes you could use some pretty quick math to be able to decide exactly how far it is. Just use some intuitive thinking. That takes care of us there. I'm getting my dog's right here. I'm going to show you. Come here, Bella. Yeah, I want to be able to give you guys a little glimpse in the Gens family. This is Bella right here. She's just walking by, looking for some food. They're always hungry anyway. So anyway, miss you guys. Love you. You should be able to do those first few problems. Don't worry about graphing it. Just make sure you can do the modulus. Just a few problems. You get going, be good to go. Later.